Good afternoon, everybody. My name is Sebastian, and I'd like to extend a warm welcome to all of us joining us here today. I'm here with my two colleagues, Enrique Bermejo and Alejandro Manzanares, and both of them are AI researchers at Panacea and as well members of the Zibian Labs product team. So today we're going to try something slightly different. The format will be a bit more dynamic than our usual events. So if you have attended our sessions before, you might notice a few changes. And if this is your first time with us, well, thank you for your patience as we're experimenting a little bit with this new setup. So the idea for today is we will start with a short introduction to the idea behind Zibian Labs, followed by a presentation from Enrique on our new handwriting examination tool. And after that, Alejandro will walk us through a little demo. And once we finish the demo, we will open a roundtable discussion on how the technology works, how we have trained it for the different languages, etc., etc. During the entire event, your questions and contributions are very welcome. We'd just like to ask you for one thing. Please share them via the chat first and use your microphone only when invited, okay? So this way, we can keep things running smoothly. And a final disclaimer before we start, none of us are handwriting experts, right? We're all computer scientists, so please forgive us if we get the terminology wrong here and there. So, well, once again, thanks for joining us today, and let's get started. Actually, I'm giving the word to myself because I have to talk about the first thing. So basically, what you see here is the brand new Zibian Labs webpage. You find it at zibianlabs.com. And I just want to take a moment here at the beginning to tell you about Zibian Labs and what's the idea behind that. So Zibian Labs is part of Panacea. And basically, we build AI tools to help forensic experts do their work more efficiently. The idea in itself is pretty simple. There's a lot of repetitive and time-consuming work in forensic analysis. And we want to give experts tools that save time, but don't take any decision-making away from them. So our AI doesn't replace people. It helps them focus on the parts that really matter. So at the moment, we have basically two tools. One is for facial comparison. This one helps analyze videos or images of people, and it picks out the best frames, checks their quality, and guides the experts through the comparison process. It even helps generate reports that follow the international standards, and which can be a big time saver. We will present this tool actually in November in a similar event like the one we're doing today. And the other tool is a handwriting examination tool. I won't go into this because the entire event is about this. But what this illustrates is that, well, more tools will follow over time. A few more key points about Zibian Lab is that all our tools operate offline, ensuring that no data is sent to the internet, and the AI is trained using ethically sourced data. We will talk a lot more about that during the event. And that's basically the heart of it. The idea of all the Zibian Labs range is to give the forensic experts smart tools to make their work faster and easier and more precise while keeping them in control. So that was basically my quick introduction to Zibian Labs. And I hand over the word to Enrique.
Thank you, Sebastian. Today, I will explain the essential parts of the research that have led us to work in this area of document examination. So I will introduce the challenge we are addressing and the methodology that we have been following to assist with AI in this forensic process. Then we will show some experiments that we have performed so far and some ideas that we have for the future. So, as you know, there are many details to analyze during an examination of documents. And as this process is done manually and is time-consuming, usually a trade-off is met. Or either you analyze fragments or smaller documents, and the reports only contain a few samples when the documents are too tedious to process completely. So with this in mind, we were faced with a key question. So how can we use AI to improve the efficiency of the process? We are used to work with images, and generally the first step consists in detecting patterns in the images. This is a difficult task because of the different variability of handwriting styles. Then we look into advances in OCR techniques, as we know that the AI is beginning to understand handwritten text despite this large variability. And we can also use the AI to provide automatic ways to compare and match databases of documents or flag or highlight important documents. But essentially, another thing that is relevant for us is that AI can be used to reproduce the workflow of the analyst until the generation of reports. Then our goal is to provide tools that can improve the efficiency of the forensic process as a decision support system with the expert when the expert is always in charge with these tools. So our approach has been to start with the basics. So we have designed a pipeline that detects patterns in the image and tries to isolate them. We can detect lines, words, or characters in the images. And then in parallel, we try to understand them with a dedicated OCR system. This is designed specifically with handwriting in text in mind. But in the middle, we found that the slant of the text has a great influence in both the detection and the recognition. So we had to take this into account and apply some corrections to improve how the detection is made. With this information, we are able to correlate elements in the image with their meaning. And this way, we know their location in the document. So the previous idea is summarized in this graphic. So to assist with the process, we are interested in processing both a question document and a reference one, and detect patterns and recognize the text in them. So with this information, we are able to compare them and perform word or character searches and make the process more agile until the generation of reports. But we want to do this to improve the efficiency of this process. So I will go in detail now about the parts of the workflow. So the first step would be the most important one, the line detection, as everything will depend on how well the lines are detected in the image. And errors, it's important to take into account that errors in this stage can propagate to the following steps. And this needs to take into account some things, particularities of the handwriting, like the irregular spacing, the slant, overlap, or some notes. The underlying part of the process is based on AI models that can process images and results in heat maps. With these heat maps around the characters, we can try to detect lines and compose words in the regions of the text. So we use this to detect lines. And this image should show two different models that we have been trying to integrate in this process. The model in the left shows how, thanks to some parameters, a user can improve and can tweak how the automatic algorithm detects lines. And the other one is like a black box. It takes an image and produces an output. We don't have any kind of control with this other algorithm. So we decided to go with the left one, because it provides more flexibility and also overall good results, so that we can let users to refine what the automatic models results. When we have the lines detected in the image at a word and a character level, we use an ad hoc process based on computer vision, and using these lines, we are able to measure pixels between characters or words. This is done using a histogram of the color pixel in the image, and we can also use this information to measure the spacing or other interesting values. Once we have detected the words in the line, we are able to isolate the letter if there is some kind of space in between. However, as I said before, we found that our approach was not working properly when dealing with text inclination. So at a document level, if all the text has a similar inclination, we're able to estimate the level of slanting in this image, apply a correction stage to the image, and then perform this pattern detection. The following image shows how can we improve with this correction, how the lines, the letters, and the words are detected in the image with inclinated bounding boxes. Then, as I said, this part was the pattern detection, and we use an AI model trying to convert the handwriting text into digital text, like a normal, a regular OCR, but adapted to handwriting, different handwriting styles. This produces transcripts directly from the detected lines in the image. We decided not to apply any kind of correction after the prediction to avoid correcting a real spelling mistake in the text. Then we are able to correlate both information, the detection and the recognition, and link the elements in the transcript with their location in the workflow. At the moment, we specifically train the different AI models to 4 languages: English, French, German, and Spanish, with policy in the future. This runs on GPU hardware, so this is our models are able to deliver fast and scalable results. And as Sebastian said, this works on offline and on your computer. It doesn't connect to any kind of cloud. In this image, we are seeing some examples of different transcripts made in French, in German, and in Spanish. And this is like a recap of the graphic I showed before. We are focusing now on the final part of our pipeline, of our workflow, and it's summarized. We are trying to say what can we do with the information we have compiled so far. So, as I said, the transcript is linked with the precise location in the document of the elements that we have been detecting, and we can build an structured database generated for each one of the documents. And we can perform some kind of cross-document queries, so we can compare the same letter or word in both documents and find where they are. This way, we can extract, we can crop from the images or the PDF files. We can crop these elements and extract them to any kind of device that we are interested in post-processing the data or generate a report. So now that we saw the whole workflow, we can try to measure how this approach could perform. So first, we are going to measure the precision of the handwriting OCR, isolated from the rest of the system. To do so, we can compute different metrics, like the character error rate or the word error rate. That are those of the most used metrics in OCR. And these measurements give us an overview of how accurate the AI models are when understanding the text. Then, after correlating the detected patterns with the transcript, we measure the number of hits obtained by the proposals. We're able also to perform some metrics on this. And for this, we are using open source data that you may already know, that like AM or CBL datasets that are in English, or the range database that is in French. We selected some cases for validation. And here are the results. So in the table, we can see the metrics for each language that we currently have, performing around between 5 and 8% of errors. That translates into editing 2 or 3 elements in the lines of the resulting transcript. So this really is the work of understanding what's in the text. When we look at the detection accuracy, we see that we are able to detect lines almost perfectly. And when we mix the whole pipeline, the detection and the recognition, we barely lose accuracy. When considering words, the accuracy is lower. However, some errors are really minor misdetections that can be easily solvable, like the ones in these examples. We either miss a letter in a word because of the spacing, or we find a word split in two. If we consider the efficiency of the process, we see that the solution is really fast, spending between 1 or 2 seconds per page. This is because we are using a dedicated GPU with at least 4 gigabytes of RAM, so having a modern gaming PC really helps. And we know the AI is not always correct, and that's why we need people supervising and experts doing the actual evaluation. But we believe that this could be a strong support to the process. And the first thing listed here is as a limitation is not really a limitation per se. We know that our solution will be the most beneficial when processing longer documents. That's where the most productivity we can improve. And besides that, we saw that our system struggles at this moment with mixed printed and handwritten text. Also, we already have another AI that can help us with that. Regarding future works, we plan to make the most of the information we already extract, and this way we could address the detection of ovals, or baseline or midline text in the image, or integrate the pixel measurements, or even address the automatic comparison of documents and ranking that we know it's also an interesting topic. So in summary, we believe that the automatic system that we can have devised could be a helpful tool, enabling this side-by-side analysis of documents by querying elements in them. We met our first goal that was try to save some time and effort by expediting things like the report generation. And maybe that's all for me. I will leave Manza to show us a demo of how the software works.
Thank you, Enrique. Let me share my screen to you all. Okay. As Enrique said, I'm going to show you our application in a demonstration and how we apply the scheme of the workflow that Enrique showed us inside our application and a couple of cases that we have prepared to show you. Okay, so first of all, this is our welcome window with you can see a little bit of information. First of all, what you can select is the language which the apps work with. This is the language of the application. It's fully translated to French, to German, Spanish, and English. And this, thank you. Thank you. And this selection is tied to the language that the report is going to be generated also. If you work with the application in English, your report is going to be in English, but there's no problem if you want to change if you want to change the language. And also here you can select the transcription language. Here you have also the same 4 options. And changing that, you can load different OCR engines to perform transcription in different languages. So to start analysis, first of all, we need to press this button here. And in this window, you can see that our main functionalities, we allow you to load 2 documents, a questionnaire one and a reference one. So we go here and we load one of our documents. No, sorry, this folder. Yeah. So we allow you to load documents in PDF format and also in PNG format. So you can work with the images or PDF documents, and when you load the document to the application, it starts automatically to detect and to transcribe the text for each page. So it takes like Enrique said, like a couple of seconds per page. So here you can say the initial transcription and text detection that the model has performed with the default parameters. We gives you a default configuration that we think that works well in most of the cases. Here you can see how the detection is for each of the pages, but you can also go here and configure the detection. So also Enrique said the first part and one of the key part is we need or we want to have a good line detection in order to have a good transcription. So here we have a couple of parameters that we can tweak in order to modify this selection here. So for example, we can lower this value here. These both values basically selects which pixels are classified as text or which pixels are classified as background. So it allows you basically to have wider or narrow bounding boxes surrounding the text. So modifying this parameter, I think the adjustment is pretty okay. Now, when we finish the parameter adjustment, we need to apply the changes, and then it performs again the transcription process. And also takes a couple of seconds to give us a new transcription. And here we need to review or to modify, or we can modify two main things. First of all, we have the transcription. For example, here this transcription is fully editable, so you can modify whatever the model has misdetected. For example, this it detected 17 instead of 27, or well, you can modify this text here as much as you want to match the actual text that you can see in the image, and also you can tweak how the words and the letter are detected. Here you have also two parameters that are word sensitivity and letter sensitivity. And what you can do is to be a little bit more restrictive with the detection of the words, and also a little bit more restrictive with the detection of the letters. If you go up, you are less restrictive, and if you go down, more restrictive. Okay. So now, once you are okay with the detection of lines and also with the segmentation of words and letter, you can also apply the slanted processing that Enrique showed us in the earlier presentation. Also apply the configuration for all the pages, but you can also go page by page, reviewing that the transcription and the detection is also okay. For example, for this page is pretty okay. And for this one, you can see it misdetected 2 lines as one. So what we can do is also modify this parameter here. In this case, we want to adjust it a little bit higher. And we need to apply the changes again. And it takes a couple of seconds to give us a new transcription. Again, this is completely editable. Seen any transcription, so we can proceed. Also, we need to be sure that our detection, our word segmentation is okay. Maybe in this case, we need to lower this a little bit. Okay, I think that's much better. Maybe we need to be more restrictive for the characters. I think that's pretty okay. Once we have finished with the parameter adjustment and we are happy with all the 3 pages, what we can do is just save the changes and continue for the reference document. In this case, I'm going to load this image, which is going to be a little bit faster to load. The time to process a document depends on the number of the pages. So more pages, more time, but it takes more or less the same time for each page. So here you do the same. Here is more or less the same mistake. I think if you do something like this, it's going to work better. You have also this parameter here. For example, this one, what does is it allows you to join lines to is a threshold for the overlapping lines. So if you have split lines, you can get them together in the same one. So I'm happy with this. I'm going to save. I'm going to apply the changes. And then again, I'm going to check the word segmentation. I think maybe I want to be less restrictive with this. Okay, I think it's okay. Okay, now when we are happy and we are okay with the transcription, the detection of the text in both documents, we pass to this view here, where here you can see our question document and here reference document. And the idea you can do perform queries of characters is in this document. For example, I want to retrieve and to highlight all the characters or the letters W that are presented in this text. For example, if the software automatically search for the W letters and show me. It also can show me the letter W detected in the text, and also can show me the surrounding word that contains that letter. For example, you can also search for every capital W is case sensitive, so you can search every letter you want in case sensitive, and also, for example, you can search for the A letter. And when you are happy with your detection of letter, you can pass to this view. So in this view, the software shows you a list of all the letters that match. For example, in this case, all the letter A's that are present in both documents. Here in the left, we see the A letter presented in the question document, and here the letter A presented in the reference document. So here you can select all the letter A you want to include in your report, and you can also select. You can also unselect all the misdetection that the model performs. And once you're happy, for example, let's say this is okay. This is okay. You can generate the report. So the last step is you need to assess the degree of similarity of discrepancy with a level of confidence. You can say this is very similar with a high level of confidence, and then save the summary. And you're going to say a report like this is going to save you a full edit in a full editable format, so you can edit here whatever you want. You can add your personal information or the information of your laboratory, or adjust it to the requirement you have. Here you can see both, well, two examples of the letter as representative examples, sorry, and then you can see also all the other letters that are selected to be part of this report. Yeah, you can also see here the information of where is this letter located. For example, this letter is located in the page 1, line 1, word 2, and you have information of. So you can localize the letter easily where it's placed in the document. So I'm going to go back.
Andrew, can you just wait until the end of this part, and then you're free to ask your question? Okay.
Thank you.
No, thank you.
So, okay, so well, now I'm gonna load another model with, in this case,
Are you hearing us?
sorry, can you hear me?
We are having some trouble with
Yes,
the internet.
we can hear you.
Okay, you. Yeah, so I was saying I'm going to load a different language. We don't need to close the application to start working with another language. We can select the language here. It takes a little less than a minute to load the new model. We could also, for example, if we want to present a German report, we could also change the language of the application. In this case, I'm going to leave it in English. And here we just need to, for example, load a couple of documents. We can load documents in parallel. We can load both question and reference document, and the software will start analyzing them. It's going to take like a couple of seconds. Maybe now it's taking a bit longer. Okay. So I'm going to wait so you can see both documents loaded. Okay. So here is it's pretty the same process as we saw. We need to adjust the parameter. I think this is quite good. You can see here the numbers of the line that matches with the numbers you can see here. So you can assess that the text is correctly written. Okay, I think it's okay. Here, I think we just, for example, let's say maybe we need to be less restrictive with the words. Yeah, much better. Okay, for example, we can modify the transcription, and it will save the transcription and use it for localizing letters. Okay, and then here's the same. For example, here we can search for all the letter H in the document. Well, there's a lot of H letter in the document. We can select every match that we found interesting or representative, or we want to include on our report, and it's the same. You can export it to a document to use it to present it to the judge, or to include it in another bigger report. Here, for example, we can see the capital H. We could select every of them and export it, and I have this here. It's the same report. We also give you the reference of the document that you've loaded, and the same you see here the crop of the character isolated, and here you have the work that contains that character. And last of all, I'm going to do a quick test in Spanish, so you can assess that our system is working for that for all those languages. It takes a bit less than a minute to load to unload the previous model and to load the new one. For example, yeah. In case of you misloaded new languages, your work is still here in case you want to keep working with it. But let's say now we want to change the examples. We want to work with a different case. Example, this one. I think here the same. You need to be sure that the detection of the line is okay, because it's going to affect how the transcription is performed. I think that's pretty okay. You can modify the transcription again. Then you assess that the segmentation of the words are well performed. I think better if I increase that value, better. Okay. I think it's okay. Here, I think this is going to work. Yes. Okay. And then here, we can assess the transcription is correct. We can assess here the transcription is correct. In this case, we need to be less. I think it's a little bit less restrictive with this one. Yes. Okay. Okay, I think it's okay. And then just for the last time, we can do a search for maybe capital A here. You can do the query. It's going to highlight all the capital A letters that found and shows you the line. And as the same with the other languages, you can go here and export it to the report and save this report, export it into PDF, or modify as much as you want. So I think we are done with the demo. I think I've shown you all the main core functionality that the application offers you.
Okay, thank you, Manza. Enrique, could you display the QR code? Before we start with the questions, and we actually have prepared also questions for ourselves, so there's still going to be a few things to go over. We would like to ask you if you could help us complete this survey, because we are not handwriting experts, and it would be very interesting for us to know what you think about what you've just seen. So there are two options to access this survey. If you could go back, thank you. Number one is you scan this QR code with your phone. And if you want to do it on your computer, I'm now going to share the link in the chat below. If you click on that link, you get to the same survey. So we're going to give you 2 minutes to complete it. This is really valuable for us. So if there's no personal information, unless you're using the last box to request a test version of the software, then you need to give us your email, because otherwise we don't know whom to send it to. Okay. So it's like, I think 5 questions or 6, very simple ones. And at the end, you can just request a test version of what you have just seen. Okay. We're going to stop for 2 minutes, and then we're going to continue with all the questions you may have, as well as with the roundtable we have prepared.
All right, I have a couple of questions. Going back to the split screen when you had the question document and the reference document.
Mm-hmm.
My question is, can you load on each?
Sorry.
So in other words, can you have can you create a multi-page or multiple pages of question documents on the left, and can you create multiple pages of reference documents on the right and do a search of all of those at one time?
Yeah.
Well, you can load in both cases. You can load multiple pages documents or
Okay.
Whatever longitude.
Okay. My next question.
Mm-hmm.
I understand that you are able to localize or do searches by letter.
Mm-hmm.
Does your AI program allow you, once you've transcribed both sides, the question and the reference, does your AI program allow you to select or identify common words? So if there's a word because on the left, does it allow you to identify the same words on the right in the reference documents? Or must your search be confined to individual letters?
At this moment, what we are doing is searching for the words with the occurrences of the same letter. But we have this information, and we could perform this query.
What I'm saying is, if I put into the search bar, instead of looking for the letter A, I put in a word or a string of letters, RAC, for example.
Mm-hmm.
Yeah, we have at this moment, this version of the software only allows letter, and then it outputs the words where this letter contain. But we have this information, and we can do this.
There's also maybe we should mention that this is version 1 of the software. This is the first version we're making publicly available. So there's still more work to be done. I think we lost Andrew. Now he's back.
I'm back.
Okay.
Unfortunately, I'm back.
Do you have another question, or that was it?
What was the answer? I didn't get the answer.
Sorry, you didn't get the answer. The quick answer was we can do that. It's just not implemented that way at the moment. But the information is already there. If you give us a bit of time for a future version, we can make that happen.
For whatever it's worth, it's very interesting, because when I do source attribution cases,
we lost you again.
For searches for strings of letters using the word processing program, which is the same thing that you're doing on a letter-by-letter basis. So it's a valuable tool if you can implement it into your program.
Absolutely. It should be easy for us. No problem.
Okay, interesting. Thank you for the feedback. Highly appreciate it. We have another question from Kausal.
Hi, Sebastian. Can you hear me?
Yes.
Yes.
Yeah. So it was an interesting tool. Maybe I missed it, but
there was, so one part of this tool is identification of characters or letters, and the second part should be to give some kind of score or some confidence about the similarity or dissimilarity, how the two letters or the words are same or different, right?
At this moment, we think that the expert, you are the expert, we are not. So we can
I
give
see.
this input for them, for the user
Right.
of the application, because we could perform this kind of scoring system, but we know that the current research in this matter is not there yet. It may take some time to provide faithful results of the scoring system.
All right. So, Alejandro, as of now, you are just focusing on the recognition of the letters and words and characters, right? Not on the similarity or dissimilarity.
Exactly.
Okay, thanks.
We're making this process more efficient for when looking elements in the documents.
Okay, all right. Thank you.
No, thank you for the question. We have another one from Oliver.
Hello.
Hello, how are you?
Hi. Yeah, thanks. Yeah, very interesting. I noticed that most of the samples that you showed are quite, I would say, unconnected writing, quite relatively disconnected. Has it been tested on cursive joined up writing, and how do the results compare on that? I'm thinking especially of, we have a lot of cases where writing is a struggle to read at the best of times for a human, and I wondered how it performs on doctors' writing and that kind of thing.
Yeah, maybe for an AI is not really their specialty, the doctor writing. Neither I can read this kind of documents. But we have tried this in cursive writing, and it performs really well. But the only thing that we are not there yet is detecting or isolating the lines, because they are connected. So we show the samples where we are able to segment these letters to show you how the last part of this process works. So, but this is also a good thing, because if we cannot separate the letters, we can provide the output of the whole word, and we know that detecting words, we are really accurate also with this system.
Okay. I think there was even a slide about that on Enrique, no? Like about the line detection when the lines are not straight. Is it, I think.
Yeah,
okay. Well, it's great that you have all these questions, because we actually prepared some questions for ourselves. If you want, we're going to continue with that part. But if somebody else still has a question, feel free to raise your hand. Oh, well, actually, okay. There's a question from Tomas. Welcome, Tomas.
Yes, hi. Yeah, first of all, thank you for this presentation. This is very much an eye-opener on the subject, and well, it's a huge amount of work you accomplished. But yeah, I'm still thinking what's next, because this OCR function for the handwriting, this is excellent. This has potential for very much improving our time efficiency in casework. However, this, in my opinion, this is just a first step, and I would like to ask you about this automatic assessment of similarities, of dissimilarities. Can we expect this? And well, can we expect that this will be done on feature by feature basis, rather than for the whole specimen or for document compared to the other document? Because our work is based on the ACEV model, and we have to document it very accurately. We have to have our conclusions very well supported by the individual findings. And therefore, it's important that we have all these features of handwriting separately assessed, and then the final conclusion is based on all those individual findings as a whole. So I know that the AI is inherently black box in style. However, we can break down those black boxes, those big black box, into individual small black boxes, right? So that every feature is maybe not really, we may not know really how does the AI do it, but we may have it broken down into those small pieces. Is it doable, and can we expect that this program will develop that way?
I think it's a question for me. Regarding the first thing that we are going to show you next, some things for the future that we have been working on and planning. We know that the AI can participate in some of this kind of analysis, and smaller analyses are, as you mentioned, better than a big, huge black box. And we can expect that when we finish this one with this this approach, we want to take more work for us in this matter. So you can expect us to work on this for a longer time, hopefully. I don't know if I told you. We will. You can expect that to keep working on this.
I mean, the response we are getting today is pretty impressive. So, like, I think the development is definitely going to go ahead. And actually, we now have a few things that go a little bit into that direction. If you want to go to the next slide, Enrique.
Okay.
Well, the one after that one.
Maybe this one.
Yeah, maybe this one. This one works. Okay, so basically, we want to look into a few things. And one of the key questions is, how do we train the optical character recognition? If you could like fill us in a little bit.
Okay, so well, as we
because
said,
the data is coming from somewhere.
Yeah.
Models need to be.
we said before, we support only 4 languages in our system. So this is not a generic AI that understands everything, because this problem is not trivial. So we have to train a specific AI model for every language to ensure that the accuracy we obtain is the best possible one. So to do so, we need a large amount of data, and we train the AI in 2 steps. So the first thing we do is generate synthetic data, and we more or less we need like 100,000 samples of lines of text in a synthetic way generated by the computer. But then we need real data to show the system the real variability of the handwriting. So we collect from more than 100 volunteers, we collect some samples. So first here in this image, you can see how this synthetic example looks. We use computer handwriting fonts to provide awareness to the language vocabulary. So we use sentences where all the letters are the same. But this is just a start, because then we also feed the system with more advanced computer-generated examples that mimics how the real handwritten style are. So with this information, we are able to have an AI model in a language. But the second one, you are muted.
Yeah.
Sebastian,
You're muted. We can hear you.
I'm just talking to myself. So basically, we obviously know that there's more languages than 4 in the world, and I know, for example, that Tomas has also a big interest in adding his language to this mix. So what would we need to do that? To add not any other language.
Yeah, well, to answer that, and also linking what Enrique just said, is like we can generate synthetic examples of any language we want, because we just need to find handwritten computer fonts, and well, it depends on the language. Maybe it's easier or more difficult to generate example, but we can generate this synthetic example. But what the issue with that? The generated examples are easy to generate and they give us a good starting point, but we need real handwritten samples because the synthetic data doesn't capture the particularities of the handwritten samples on the real handwritten text that we can find on the wild, on the cases that you, the expert, are going to work with. So in order to be able to have handwritten samples for people that want to collaborate with us, we have designed template system. So if you can go to the, thank you. So we can design a template system that looks like this one, where we can generate automatically any number of templates that we want in order we can share it with people that want to collaborate with us. For example, in this case, let's say we want to train a model that understands Spanish, so we can generate a bunch of templates with a Spanish sample, give them to the people, and then retrieve the samples and process them to train the model. So the idea is in these templates we generate a huge amount of templates because we obtain the text for random sources from internet sources like Wikipedia. So we didn't want to add bias to our model. So we use random text in order the model can understand how to translate any kind of word in more or less any kind of context. If you can go back, thank you. So the source of that kind of templates are text obtained from sites like Wikipedia. We also had a semi-automatic text retrieval system. That means that we can share the templates, and then when the people scan them and send back to us, we can obtain semi-automatically the text, because we can obtain the samples, but we need to review that the samples are correctly transcribed, because we need to be sure that the data are good to train our model. So talking about the structure, we don't just use random text, because we wanted to add more relevant information. We also add information like dates in number and in handwritten, dates, number, and also names and document IDs. And this is fully adaptable. We can change this to any language we want and adapt it to I mean, the people, the Spanish people doesn't have the same names that, for example, Polish people. So we can adapt the generation system to generate templates in a wide variety of languages and train the models to understand them. So I think, yeah, and also for last of all, for not to add bias to the modeling based on the length of the phrases, we have two different designs, like one in landscape mode with longer phrases, and then when in straight mode with shorter phrases. So here you can see an example of Spanish templates. This is an example of Portuguese templates. All the templates have the same structure. You have on the header information for us that has the document name and data that are useful for us. You also have a block with the instructions, so each people can understand what they have to do and how they need to fulfill this document. And then also you have the block with you have the transcription of the text you need to transcribe, and blank square where you need to write the text.
We don't collect any kind of personal information. So.
Yeah, we'll just collect your handwritten, so technically we could identify you if we have to sample, but we don't collect your name or your ID or anything like that. We just need the handwritten samples. So this is another example, a more difficult one, because this is in Polish. So you see, we can generate text in whatever language we want, or we can adapt it to the particularities of each language, which is own alphabet. And we just need to reach to that 5,000, 10,000 sample. So we need 1,000
for 100 of people.
Yeah, for 100, we need 100 of people. to help us. So it's not like we need to collaborate. If we want to collaborate, we need really manpower to fulfill these templates.
Here again is Thomas' question from earlier. So what are we currently working on?
So, well, in the previous presentation, we saw that some issues and things that we would like to integrate in our system, like the oval detection and its analysis, probably. But at this moment, improving the current system is our priority. So on one side, we are addressing complex or edge cases that we may encounter on a day-to-day basis, like providing having some variability in the overall text slant or presence of lines or grids or erasures. And for example, in this image, we can see that we can exploit the information that we currently have, like this heat map that I was saying before, or the statistical analysis of the spacing to improve how we can detect words and isolate letters. And on the other hand, we are improving the quality of life when using the application by adding more compatibility and functionalities. But the most important thing that for us right now, that will be our next update in the following weeks, is improving the accuracy of the detection. So going from horizontal text detection to having more flexibility and include lines or grids in the text that are so frequent in the next examples.
Okay, thank you, Enrique. I don't know if there are any more questions. Also, not a problem. If you have a question later on, just feel free to send us an email. I think in a few slides we have our contact information. While we are waiting for more questions.
I will interrupt you because
okay. Go ahead.
Alejandro will share his screen now to show you an example of the cursive writing that we were mentioning in the question before. And just a little bit, so we can show you how the system also works with this kind of samples.
So we just need to load our both documents. Here, answering another question, you can see you can load both documents that are two-page documents, each one.
So the transcript of the element.
For example, you can see
a little bit because the screen is very small. And we can see that also with this kind of cursive writing, the system also is able to provide a really good transcript. Okay, that was only just to answer this.
Oh, fantastic! You delivered proof that it also works when the letters are connected. Okay. Yeah, as I said before, if you have any questions later on, thank you very much for being with us here today. Next month, we have a similar event, and we're going to focus on the new tool we have for facial comparison. In case you're interested in that as well, you're obviously invited, or please spread the words to your colleagues that might be working on that side of things. And if you go one slide ahead, you can also show our contact information in case you want to talk to us.
Thank you very much.
No, thank you for coming.
thank you.
It's been a pleasure. Lots of applause. Thank you so much. All right, everybody, have a great day. Thank you so much for coming.
You too. Thank you.
Bye. There it is.